12-4 continues segment relationships in circles. Intersecting chords theorem. Interior segments are formed by two intersecting chords. The theorem is, if two chords intersect within a circle, then the product of the lengths of the parts of one chord is equal to the product of the lengths of the parts on the second chord. So basically, you have a circle here, chord AB, chord CD. They're intersecting at E. A times B, if this is the chord AB, if you go from here to here, multiply A times B, is equal to C times D, if they're intersecting. It has to be within the circle, inside the circle. So A times B equals C times D. This is called intersecting chords theorem. Intersecting secants and tangents. Exterior segments are formed by two secants or a secant and a tangent. Here is a circle with two secants. Secants means a line that intersecting at 2 points on a circle at each end, and then there's two secants above out of the circle, and then these are the exterior segments. This one is a secant right here, CA, and then tangent is just intersecting at 1 point outside like this, this is a tangent. So exterior segments are formed by two secants or a secant and a tangent. This is the tangent. Intersecting secants theorem. If two secant segments are drawn to a circle from an external point, then the products of the lengths of the secant and their exterior parts are equal. So right here, if I draw two secant segments, this is AC, that is one secant, another secant. Then if I actually, here you have AB, this is the secant, you have CD. The exterior parts are right here, A and C. So right here, A times AB, okay, this right here, A times AB will equal C times CD, okay? So basically, this outer part times this whole secant line segment is equal to this times this whole secant segment. They equal to each other. How do I remember it? Outside times whole equals outside times whole. So here, the way you remember this formula from secant, when you have two secant like this, you do outside whole. So outside, this is A, that's the outside of the circle, times the whole equals outside times the whole. So the way we used to remember back in the day, we say octopus, whale. So octopus times whale equals octopus times whale. Outside times whole equals outside times whole. So I use octopus whale times octopus times whale equals octopus times whale. So I'll use it as octopus whale, octopus whale. Octopus means outside, whale, whole, octopus outside, whole. That's how I used to remember it. So let's take a look at this circle and two secant segments. In the figure, if BC is 6 right here, this is 6. AD is 2. AB is 4. Find this one. So basically, outside times whole equals outside times whole. So we're going to do AC equals AE. So right here, you're going to do 4 times 10 because from A to C is 10. 6 plus 4 is 10. So the outside is 4, AB, times 10, which is 40, equals 2 times 2 plus X. Now, if you do the distributive property, 2 times 2 is 4, 2 times X is 2X. Subtract 4, 36, divided by 2, this is 18. Secant and tangent theorem. The square of the length of the tangent equals to the product of the length of the secant and its exterior segment. So right here you have a tangent line, you have a secant line. Okay? Tangent is 1 intersecting, secant 2 intersecting, like this. So right here you have A squared, right here A squared is equal to B times the whole thing. So outside times the whole. A squared is B times BC. This is only for tangent and a secant. Okay? So that's why secant tangent theorem. Alright? So that is the theorem. How do I remember it? Same thing. Outside hole, outside hole. So here, outside hole, so you just have to, if you look here, it's A squared, which means A times A, right? So A squared is A times outside the whole thing, this is the whole thing, A times A, equals outside the whole thing. So for secant, 2 secant segments, and secant and a tangent, it's the same formula. Just for tangent, you just multiply this again to itself, A squared. And then B times BC. They equal to each other, okay? So it's the same kind of concept. So let's look at the example here. You have 25 for the whole secant line. Outside is 9, and we want to find the X. So 9 times 25 is 225. X squared is X squared. Square root of 225 will give me 1X, which is 15. So this one is 15. So let's take a look at, this is just a sample problem. So let's say you have a secant and a tangent, 12 and 10, and then you have X plus 6. So here, when you do this and solving for X, you do 12 times 10, and then X plus 6 times X plus 6, because you have to multiply this to each other. So what you can do is X times X plus 6 times X plus 6 is X squared plus 12X plus 36 equals 220. Okay? If you actually use, right here, if I actually use X plus 6 square equals 220, you don't have to worry about this part. You can just do square root of each one. And then X plus 6 equals plus minus square root of 220. And then you're going to subtract 6. So the answer is negative 6 plus minus 2 radical 55. Because if you simplify this, you get 2 radical 55. That will be the answer. So this is like a little bit of challenging problem.